Hey Internet, welcome to Solid Mechanics tutorial. So we have a single bar with dimensions of 32 millimeters in width and 14 millimeters in thickness. We have a diameter of 12 millimeters for the pins. We want to find the average normal stress for the link YW, so the vertical one. For part A, where theta is 0 degrees, and part B, where theta is 90 degrees. So step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So we've got some forces acting here, and it is pinned on the X. Okay. Step 2, list all the given values and unknowns, which is what we're trying to find. So really what we're trying to find is sigma, which is the normal stress. But in order to do that, we need to find the force of YW. So they give us 21 kilonewtons for the force that is acting on the link. However, they haven't done the calculation for the theta just yet. So that's part of our calculations. They give us part A and B, which is 0 and 90 degrees respectively. They give us the angle where the link is at X, so 30 degrees right here. They give us the length from X to Y, so that's 310, and then Y to Z is 160 millimeters. They give us the width, which is 32 millimeters, the thickness, which is 14 millimeters, and the diameter, which is 12 millimeters, as seen here and here, and then the pins are 12 millimeters in diameter. Step 3, find the normal stress formula. So sigma is normal stress is equal to F divided by A, so force divided by area. So for part A, we'll solve that first, and then we'll solve for part B last. So step 4, find the force for theta A. So using the free body diagram, the sum of the moments equal to 0. That's our assumption. We then have the angle at 0 degrees. So the formula that we use is the total length multiplied by the sine theta multiplied by the force minus the length of xy multiplied by cosine theta x multiplied by the force of YW, which is what we're trying to find, is equal to 0. So what that really means is 0.47 meters. So how they got that 0.47 is that they added the 310 plus the 160 millimeter, then divide by 100 to become meters. So that's how they got that. And the sine comes from the 0 degrees, and the 30 degrees is from the X angle. So 30 represents this, and the sine is based on part A where it has 0 degrees. Alright, minus 0.31 meters. So that is the length of xy. So xy is this portion, x to y. Cosine 30 degrees. And then the unknown is what we're trying to find. So you put this in your graphic calculator or you write some code and it will come out to be 18,382.09 newtons or 18.38 kilonewtons. Step 5, find the area for the tension loading for part A. So what that is, it is the width minus the diameter multiplied by the thickness. So 32 minus 12 millimeters multiplied by 14 millimeters, that's 280 millimeters squared, or 0.000280 meters squared. Step 6, find the normal stress for part A. So that's 18,382.09 newtons divided by 0.000280 meters squared. And that will give us 65 million pascals, or 65.65 MPa. Alright, so we've just solved for part A, the average normal stress. Now we're going to solve for part B at 90 degrees theta. So once again, from our static calculation, the sum of the moments equal to 0, and the theta for part B is 90 degrees, so that means it will be cosine. Once again, we plug in the values, so the numbers will be the same, and then the second half remains the same, but the first half changes from sine to cosine. Everything else remains the same. So our force of YW is minus 31,838.71 newtons. It's negative because it's compression. So because it's being squeezed in, the force is going the opposite direction. That's what that negative sign represents. So that is minus 31.83871 kilonewtons. For the area of compression for part B, that's a typo. So it is just the length of xy multiplied by the thickness. So 32 millimeters multiplied by 14 millimeters. So that's 448 millimeters squared, or 0.000448 meters squared. So part 9, or step 9, find the normal stress for part B. So that is minus, actually that should be newtons. So minus 31,838.71 newtons divided by 0.000448 meters squared. So I think that was a copy and paste error. Okay, so that actually gives us 71 million pascals. So our final answer will be minus 71.07 MPa. The minus just represents that it is a compression average stress. Disclaimers, the method is correct. However, I do make calculation mistakes, as you saw with the many typos. I highly encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC, just in case this video or channel gets taken down. So, you can do this by using Snipping Tool. If you never used Snipping Tool before, you can follow the instructions. If you have got a Mac, you can use the Mac equivalent. So click on the icon in your taskbar. If it's not there, go into your Windows search, type in Snipping Tool, open it up. Click on Video option. Click on New. Left click and drag the rectangle to cover the YouTube screen. Hit the Start button in Snipping Tool, wait for the countdown, hit the Replay button on YouTube, let the video finish, hit the red square in Snipping Tool to stop recording, and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends, because this is a made-up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, most likely, leave it in the comment sections. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.